H3. So first thing we got to do, count up the total number of valence electrons, right? So nitrogen, right? We have one nitrogen. Oops. One nitrogen. How many valence electrons? 5. All right. We have 3 hydrogens. Each hydrogen has 1. So that's 3. So we have a total of 8 electrons. We have a total of 8 electrons to dish out. Okay. So one thing to keep in mind is hydrogen can never form more than one bond. So hydrogen will never, ever, ever go in the middle of your compound. Okay? So if there's hydrogens bonded to something, nitrogen has to be in the middle here. Okay? We're going to put nitrogen in the middle. We're going to surround it by hydrogens. Okay? And we're going to bond them together. Okay, how many electrons did we use? 6. So minus 6. We have 2 left over. Are all of the outside atoms happy? Yes, they are. Every hydrogen has 2 electrons. So we're good. So this is one of those scenarios. We have extra electrons. Where do they go? In the middle. In the middle, minus 2. We have no electrons left over. We don't have any left over. You still got to double check. Is everybody happy now? Hydrogens, each hydrogen is happy. They all have 2, right? Nitrogen has 2, 4, 6, 8 electrons around it. So it's good too. That's it. We're done. That's our structure. Okay? No, remember, each row on each group number on the periodic table corresponds to the number of valence electrons it has, right? Okay. So if they're in group 1, they have 1 valence electron, right? If they're in group 2, they have 2 valence electrons, right? And even up here, I know it says 13, but ignore the 1 in front. 3, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, right? Okay. All right. That's how it works, right? And that's why they're forming the ions that they do, right? Okay. And going through all that stuff. Okay. So, you know, I'm telling you right now. All right. Excuse me. Can I borrow your chair? All right. Okay. I mean, like, oh, God, just bumped the periodic table. It's so much helpful to us. Thank you. I appreciate that. Okay. You've got to love the periodic table. It is a fantastic tool for you. Okay. You always get it. Yeah. All right. Yes. Well, hydrogen can only form 1 bond, right? So there's no way it could ever go in the middle. So nitrogen had to be the one. Okay. Usually it's the least electronegative element. In this case, it wasn't, but most times it is. Hydrogen can never go in the middle, though. No, least electronegative goes in the middle. Usually it's the least electronegative. In this case, it's not, but hydrogen can't, right? Okay. All right. Next one on your example list there. CO2, carbon dioxide. Okay, CO2, carbon dioxide. How many carbons? 1 carbon. How many valence electrons does that carbon bring? 4. Okay. We got 2 oxygens. How many valence electrons does each oxygen bring us? 6. That's 12 from there, and the total of 16. Total of 16. Okay, who goes in the middle? Carbon. Great. Put some oxygen around it. Right? Bond it together. So minus, how many am I subtracting? 4. I have 12 electrons left over. Yes. Okay. Yes. Typically, yeah, because typically that corresponds to the least electronegative. Yeah. And you'll find that pretty much carbon is like a center type of atom, all right? I mean, like it can make 4 bonds. That's the reason why carbon is so versatile, right? So carbon is typically the one that's the center if you're dealing with carbon. Okay. All right. We got 12 electrons left over. Yes. Oh, we'll get to that in a minute. Don't worry about it. We'll get there. Okay. I mean, you look at the bottom of the sheet, we got 3 carbons down there, right? Okay, so we'll get there in a minute, okay? All right, so CO2, we've got 16 total electrons. We've dished out 4 at this point, okay? Now we got to go and make the outside atoms happy, right? Okay, well, let's do that. We got 12 electrons to dish out. So what is each oxygen, how many electrons does oxygen need here? What? It has 2 right now, but it needs 6 more, right? So it brought, but that's what I'm saying. We have to dish out the electrons. How many more does it need to be happy? Correct. But that's why we got the total number of valence electrons. Now we're dishing them out to share them amongst everybody so everybody's happy. I'm trying to, if you want to go back and start doing this, and then start doing drawing the loose dot structures like that, you're welcome to do so. But I'm just trying to show you the short way to do this. You know what I mean? So around it right now, there are 2 electrons on carbon. All right? There are 2 electrons right there. It's sharing 2 electrons with carbon and oxygen. Okay? We're going to add 6 more electrons to each oxygen. Okay? 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Okay? How many electrons did we use? 12 minus 12. We have no electrons left over. Yes. Great. Carbon is not happy. So now we got to do some double bonding. Okay, we got to take some electrons away that are just around oxygen. Folks, you got to really focus right here. Right here. Because we're doing something that you're going to miss. Okay, so carbon only has how many electrons are on it? 4. It needs 8, right? But we're out of electrons to give it. So we've got to start borrowing electrons from the electrons that we gave oxygen. Okay, so we're going to steal, this pair of electrons here from oxygen and draw it in as a double bond now. Okay, are we there yet? No, carbon still only has 2, 4, 6 electrons around it. All right, so we got to steal another pair of electrons, and they need to be shared. So I'm going to steal that other pair. Boom. Okay, and now everybody's happy. Each oxygen, 2, 4, 6, 8. 2, 4, 6, 8. Carbon, 2, 4, 6, 8. Who do we appreciate? Okay. Electrons, sorry. Okay. Okay. Everybody's happy. They have 8 electrons around them. So when you run out of electrons and somebody's not happy yet, you got to start double bonding. Okay, that's an example of that part of our steps that we got laid out here. Yes. Draw lines because that represents those electrons being shared between them. Yep. Yeah. All right, how about N2? All right, let's do nitrogen gas. Okay, we got 2 nitrogens. Each are bringing 5 electrons, right? We have a total of 10 electrons to dish out. Okay. So we just have a nitrogen bonded to a nitrogen, right? I mean, that's all there is to it. There's no like center atom here necessarily, right? We just have these two atoms. Nitrogen bonded to nitrogen, minus 2. We've got 8 left over. We got to start dishing them out. I'll go 1, 2, 3, 4, 5, 6. All right, that guy's good. 1. I'll go 1, 2. So minus 8. I'm out of electrons now, right? I'm all out. I'm all out of electrons. We run out of electrons, right? This guy's good, but that guy's definitely not, right? 2, 4, only has 4 electrons around him. So what do we start to do if we run out of electrons? Start doing double bonding, start shifting them over. Okay, so I'll steal this lone pair and draw in a bond. Okay. We good to go here, Will? No. What should we do? Hold on. Okay, we erase that lone pair. Draw in another bond. Okay. So we've got 2, 4, 6, 8 electrons there. Around this nitrogen, we got 2, 4, 6, 8 electrons there. Okay. Okay. So let's see. We're going to jump around to let's do I wanted to do an example with let's go darn, we're almost out of time. All right, this one we're going to stop for now. Okay.